Hello and welcome to today's lesson. As you can see, we are moving ahead to 12.3, where we will look at measures of central tendency and dispersion. As we complete this lesson, please make sure you have your notes paper handy and ready to go, and that you are filling that out as we do the lesson here today. So let's go ahead and get started. So our objective for today is that you all, the mathematicians, can find the mean, median, mode, and range. So to get us started, a way to summarize a set of data is to use a measure of central tendency. And we might not use that phrase very often, but basically we're talking about mean, median, and mode. Those are all measures of central tendency. The measure of central tendency that best describes a data set may depend on whether the set has an outlier. So here we have a vocab word. An outlier is a data value that is much greater or much less than the other values in the set. So it kind of doesn't fit with the rest here. So mean, median, and mode. Here's a quick summary. And this is on your notes paper to help give you a refresher. The mean is equal to the sum of the data values divided by the total number of data values, and we oftentimes call this the average. We use the mean when we are looking for a description, a way to categorize or discuss data that does not have an outlier, so not one that has something that's like way far out. The median is the middle value of a data set when we arrange the values from least to greatest. And so this is oftentimes used when we are trying to describe data that does have an outlier, so that the outlier does not heavily weight our data in the wrong direction. And then the mode is the data item that occurs the most times in the data set. You can have one mode, no mode, more than one mode, depending on your data set. So we use the mode when the data is non-numeric or when choosing the most popular item. So when we are looking at the mode, it's not an accurate representation unless it's something that's non-numeric or we're looking for the most common thing. So to get started here, we are going to find the measures of central tendency. We are going to find and calculate the mean, median, and mode. The mean is oftentimes referred to as the mean measure of central tendency, as in like mean being making us do the most work, because it does make us do the most work. So for this one, we are looking at the scores of these bowlers. We've got 8 bowlers here, and so we have to add the numbers and divide them by how many numbers we have. So 104 plus 117 plus 104 plus 136 plus 189 plus 109 plus 113 plus 104, and take all of that divided by 8. So when I add up 104, 117, 104, 136, 136, 189, 109, 113, and 104, I get 976. And then divide that by the number of numbers, which is 8, and I've got an average or a mean of 122. Let's take a look here at finding the median. When I find the median, I first need to list my orders and number from least to greatest. Looks like my least or my smallest is 104. And I actually have that a couple of times. Then I've got 109, 113, 117, 136, and 189. And then I start to figure out the middle. When I have 2 middle numbers, when I have 2 medians, or what appears to be the median, I'm actually going to find the average. So I'm going to add these 2 together and divide it by 2 to find what is actually in the middle of my data set here. So 109 plus 113 is 222. And then when I divide that by 2, I get 111. So my median is 111. My mode is what number occurs the most in my data set. So when I'm looking at my data set, the only number in this particular set that is repeated is 104. So that is my mode. So go ahead and pause and take a look at this. Got it? You are still using the scores from problem 1, but it is including or it's asking for what happens if we do not include the outlier. So go ahead and take a look at this. When you are ready to check your answers, please resume. All right, welcome back. So when we look at this, our answers, 112.4 is the mean, 109 is the median, and 104 is the mode. Which measure of central tendency best describes this data? It would be the mean, because we no longer have the outlier. We no longer have the score that's further away from the rest. So, something that I did not mention when we were looking at the previous, like the actual problem 1, one of the things that we want to keep in mind is that when we are looking at the data for the bowlers here, 189 is an outlier. And so if I'm trying to summarize my entire set of data, using the mean is not the best representation of the data because of that outlier. 189 is so far off from the rest that the mean is not an accurate representation. So the median would be better in this case. But in our got it, the mean is the best because we got rid of that outlier. In problem 2, what do we need to do in order to find a data value? Well, my 3 grades on exams are 80, 93, and 91. And I am looking to get, what grade do you need on the next exam to have an average of 90? I know that to find the average, I add together all my data values and divide by the number of numbers. So I'm adding my 3 current exams plus my X, which is my next exam that I'm taking, dividing by 4 to figure out what this would look like. So I can first do 80 plus 93 plus 91 and get 264 plus X over 4 equals 90. Multiply both sides by 4 to get 294 plus X equals 360 minus 264, from both sides, and get X equals 96. So in order for this particular person to get an average of 90 on their tests, they need to get a 96 on this 4th exam. Now, I do want to pause for a quick side note. Some people have started to ask me about exams and what do I need to get on my exam in order to get a certain grade in the class. Our grades are weighted, and so the quick explanation is that you solve it differently than what we just saw in this problem. And if you have questions about that, you can ask me and I can help you out. At this time, you do have a got it question. So if you could please continue on here, pause your video, do the got it question, and then when you are ready to check, press resume. All right, welcome back. The answer for this would be 88%. And so for the second part here, if the highest possible score on the 4th exam is 100, is it possible to raise your average to 92? The answer is no, because in order to do that, you would need to get a grade of 104. And as stated in the question, you cannot get above 100. So next here we have a vocabulary word. A measure of dispersion describes how dispersed or spread out the values of data, the values in the data set are. And so, in order to think about that, we look at the range of the set of data. It's the difference between the greatest and the least data values in your set. So, when we look at problem 3, the closing prices in dollars of 2 stocks for the first 5 days in February are shown. What are the range and mean of each set of data? So, in order to find the range, I am going to first subtract the largest minus the smallest. For stock A, that would be 47 minus 25, and that gives me 22. For stock B, that would be 36 minus 28, and that gives me 8. So I've got a range of 22 and a range of 8, and then it does also ask me to find the mean. So I do 25 plus 30 plus 30 plus 47 plus 28 and divide that by 5. And for that I would get 160 over 5 or 32. For stock B, I would add 34 plus 28 plus 31 plus 36 plus 31 and divide by 5, and I would also get 160 over 5 or 32. So when we are looking at this, it does at the end of our question say to use the results to compare the data. So as you can see, both sets of stock prices have a mean of 32, so that is the same. But the range for stock A is 22, while the range for stock B is only 8. So go ahead and take a look at the got it here. Please pause your video and try the got it, and when you are ready to check your answer, please resume. All right, welcome back. Here is your answer for problem 3. Got it? Stock C, we've got 6 and 4.2. For stock D, we've got 22 and 11.2. And again, it does ask in the question for us to compare our results. And so for this, stock C had a range of 6 and a mean of 4.2, while stock D had a range of 22 and a mean of 10.8 over this 5-day period. I'm sorry, not 10.8, 11.2. All right, problem 4. The results of a student survey are on the number of televisions in the household are shown on the line plot. We need to calculate the mean, median, and range of the data. And then also, is there a way to tell from the graph that the mean and median are equal? So as we take a look at this problem, we first need to calculate the mean. When I'm calculating the mean on a line plot, what I can see is that I have 2 marks with my 1, so that tells me that there are 2 there. I've got 4 marks on my 2, so I'm in my head doing 4 times 2 to tell me to add 8. 1, 2, 3, 4, 5, 6 marks on the 3 column, and so I'm going to do 6 times 3 and add 18. The 4 has 4, so I'm going to add 16, and the 5 has 2, so I am going to add 10. But to calculate the number of numbers, because what I have here does not represent how many values I have, so I'm going to come back over to my line plot and count the x's. When I count the x's, I see that there are 18 data points here, so I'm going to go ahead and calculate the mean with that. And it ends up being 54 over 18 or 3. When I'm finding the median, I first need to list my numbers in order from least to greatest, and this line plot actually makes that quite a bit easier. I've got 1, 1, I've got 4 2s, 2, 3, 4, 5, 6 3s, 4 4s, and 2 5s, and then again finding the middle. And because they are both a 3, I could add them up and divide by 2, but that is just going to equal 3. So my median is also 3. And for my range, I'm going to do the largest subtract the smallest, which would be 5 minus 1. So my range, I'm going to write it up here, my range is 4. So how can we, or can we, tell from the graph that the mean and the median are equal? And the answer to that is yes, we can. When the graph is symmetrical, then we can determine that the mean and the median will be equal to each other. So it can save us some calculations. So go ahead and pause your video and try got it number 4. When you are ready to check your answer, please resume. All right, welcome back. Here is your answer to got it for number 4. And again, I want to highlight, can we tell from the line plot whether the mean and the median are equal? And in this case, the answer is no, they are not equal, but yes, we can tell. In this particular problem, the data is not symmetrical, so because of that, the mean and the median are not equal. All right, so for number 5, the quiz results are on our line plots here. We've got class A and B, we've got quiz scores, and we are looking for which class has a higher standard for being in the top half of the quiz scores. By comparing the line plots, can you tell which mean is greater? So I'm going to start with the second part and just kind of use that to help myself make a prediction. When I look at how the data is scattered, in the first one, in class A, it does appear that the data is kind of more spread out. I've got 3 and 4 being my highest ones, and then it looks like 1, 2, 5, and 6 are symmetrical to each other. So that tells me that the mean and the median are equal, but also my data is a little bit more spread out. In class B, that is not the case. All my data is kind of on that far end, the 4, 5, and 6, tells me my mean and median would not be equal. When I take a look at finding the median, I can start by just using my line plots, crossing out largest and smallest until I find my middle number. And because on this line plot my number is already ordered from least to greatest, it makes it nice and easy for me. So I've got between 3 and 4. Well, I know that halfway between 3 and 4 is 3.5, so my median for class A is 3.5. For class B, again, canceling numbers out to find the middle. And I've got 2 values of 5, so my median for my class B is 5. So for this particular set of data, class B has a higher standard for being in the top half of their quiz scores. And as we compare, like I said earlier, as we compare the graphs themselves, the data for class B is shifted to the right when compared to the data for class A, so the mean should be greater. Go ahead and take a look at the got it, and when you are ready to check your answer, please resume your video. All right, welcome back. Here is your answer. For the first question, it is less. For the second question, it is also less. And for the last question, how can you tell which data has the greater mean by comparing the graphs? The data for class C is shifted to the left when compared to the other ones, especially compared to A and especially B. So therefore, the mean will be less in graph C because of the shift to the lower numbers on the graph itself. Alright, so at this time you are done with this lesson, so please make sure you show your completed notes paper.